Hi, welcome to the Autonomous Database lesson. My name is Sanjay Narvekar. I'm a product manager in the Oracle Cloud Infrastructure Field Enablement team. I'll be walking you through this lesson today. Here's a quick look at the Safe Harbor statement. Now let's look at the objectives for today's lesson. In today's lesson, you will look at the features of the Oracle Autonomous Data Warehouse Cloud Service and the Autonomous Transaction Processing. You learn how you can launch these services in Oracle Cloud Infrastructure, and you'll learn how to connect to these services using SQL Developer, and also get familiarized with scaling up or scaling down these databases once they are provisioned. And you'll also look at the out-of-the-box capabilities of backup and recovery, as well as monitoring that is included with the autonomous services. The Oracle Autonomous Database is actually a family of products with each member of the family optimized by workload. The first member of the family to become available in March of 2018 was the Autonomous Data Warehouse, or ADW, which has been optimized for analytic workloads such as data warehouse, data marts, or as part of a data lake. The second member of the family that became available is Autonomous Transaction Processing, or ATP. ATP is optimized for transaction processing or mixed workload environments and makes an excellent platform for new application development. Both ADW and ATP share the Autonomous Database Platform of Oracle Database 18c on our Exadata cloud infrastructure. The difference is how the services have been optimized within the database. When you start loading data into the autonomous database, we store the data in appropriate format for the workload. If it is ADW, then we store data in columnar format, as that's the best format for analytics processing. If it is ATP, then we will store the data in a row format, as that's the best format for fast single row lookups. Let's look at query optimization. For analytics workload, we automatically parallelize the query execution to access large volumes of data in a short amount of time to answer business questions. If it's a transaction processing system, then we will automatically detect missing indexes and create them for you. Regardless of the workload, we need to keep optimizer statistics current to ensure we get optimal execution plans. With ADW, we are able to achieve this by gathering statistics as part of all bulk load activities. With ATP, where data is added using more traditional insert statements, statistics are automatically gathered periodically. As the data volumes change or new access structures is created, there is the potential for an execution plan to change, and any change could result in a performance regression. So we use Oracle SQL Plan Management to ensure that plans only change for the better. Let us now look at the Autonomous Data Warehouse service in detail. The Autonomous Data Warehouse handles creating the data warehouse databases, backing up the database, patching and upgrade the database, and growing or shrinking the database. Customers can manage full lifecycle activities for the service using the Service Console or via the command line interface or REST API. Autonomous Data Warehouse does not require any tuning. It is designed as a load and go service. You start the service, define tables, load data, and then run queries. You do not need to consider any details about parallelism, partitioning, indexing, or compression. The service automatically configures the database for high performance queries. Autonomous Data Warehouse is completely elastic service. When you get started with Autonomous Data Warehouse, simply specify the number of CPU cores and the storage capacity in terabytes for the data warehouse. At any time, you can scale up or down the CPU core count or the storage capacity. When you make resource changes for your Autonomous Data Warehouse, The data warehouse resources automatically shrink or grow without requiring any downtime or service interruptions. Autonomous data warehouse is built upon the Oracle database so that business intelligence applications and tools that support Oracle database also support autonomous data warehouse. These tools and applications connect to autonomous data warehouse using standard SQLnet connections. The tools and applications can either be in your data center or in a public cloud. Oracle Analytics Cloud and other Oracle Cloud services are pre-configured for autonomous data warehouse. Here's just a schematic of the different services and tools that support the autonomous data warehouse. So let's now look at provisioning the autonomous database on the data warehouse service. To provision the ADW database, you first log in into the console, select a region, and then specify the database name and also specify how many cores you want for your database as well as storage capacity, and then enter the admin password. The service will be created for you in a few minutes regardless of the size, and the database is open and ready for connections. The autonomous database stores all data in encrypted format in the Oracle infrastructure. Only authenticated users and applications can access the data when they connect to the database. All connections to ADW use certificate-based authentication and SSL. This ensures that there is no unauthorized access to the ADW cloud and that communications between the client and server are fully encrypted and cannot be intercepted or altered. Certificate-based authentication uses an encrypted key stored in a wallet on both the client and the server. The key on the client must match the key on the server to make a connection. A wallet contains a collection of files, including the key and other information such as the SQLnet or TNS names or needed to connect to your database service in the autonomous data warehouse cloud. Here's just a schematic which shows the different protocols that can be used and the wallet that's needed to establish a connection from the client computer to the autonomous data warehouse cloud service running on OCI. The predefined service names provide different levels of performance and concurrency for autonomous data warehouse cloud. Use high when you need the highest resource and the lowest concurrency for connecting your client to the autonomous data warehouse. Use medium when you need less resources and higher concurrency when connecting your client to the autonomous data warehouse cloud. When you want the least resources and the highest concurrency, use the low database service. With the low database service, queries run serially, and we recommend that customers use the low database service when using Oracle Golden Gate for data replication purposes. Let's now look at creating users in autonomous data warehouse. We simplify the user creation via the new database role. You needn't specify anything except the password. Autonomous Data Warehouse Cloud requires strong passwords. The password you specify must meet the default password complexity rules. We have a new role called DW role, which includes all necessary privileges for a data warehouse developer/user. So to create a user, you just run the command create user, username identified by password. You don't have to specify any table spaces when creating users. Once the user is created, you just grant the DW role to the user. You can load data into the autonomous data warehouse using SQLnet. You can use the SQL loader utility, and to do this you will stage your data files on your local computer and use SQL Loader. You can also use ETL scripts that use DML to insert and update data. The other method of loading data into the ADW is by staging files into Oracle Object Store, and this is the preferred technique for large volumes of data. Once you stage the files in the Oracle Object Store, then you'll load data into the database using new PL/SQL APIs. We also support OCI Object Storage Classic, AWS S3, or Microsoft Azure for staging data. The files can be in any supported Oracle_loader file format, and as a roadmap item, we are planning on supporting any Hadoop file format. There's a new PL/SQL package called DBMS_cloud for accessing files in object stores. There is no need to manually define external tables for loading files. This makes it easier to specify the format of the source data. Before using the DBMS_cloud PL/SQL package, you need to first define the credentials for the object store. And to do this, you will need the OCI object store username and Swift password. The credential will be stored in the database schema once, and then used for accessing the object store for all loads. And below, you're looking at the dbms_cloud.create credential execution. To load data directly into the target table without any intermediate steps, you can use the dbms_cloud.copy_data procedure. You will need to first store files in the object store and then use the credential that you created in the previous step and specify the file names using the file_URI_list parameter to the procedure, and the format is shown here. So in the case of the US Ashburn region, use US-Ashburn-1. If you're using Phoenix, it will be US-Phoenix-1. Over here, the DWCS demo refers to the tenancy name, and demo_data refers to the bucket name in OCI object storage. And finally, chan_v3.dat is the text file that has the data that's going to be loaded into the channels table. Once this package procedure is executed, the data in the chan_v3.dat file will be loaded into the channels table. We also provide you a mechanism for troubleshooting data loads. Now, the way to go about doing that is by querying certain tables in Autonomous Data Warehouse. The example for querying the data structures is provided here. A database administrator or developer will query the user_load_operations to get the name of the tables, the status of the load, the rows loaded, as well as the names of the log file table and the bat file table. In the case of errors in the data load, the developer or DBA can query the log table and the bat table. Let's now look at querying data on the Oracle Object Store. Similar to loading data into Object Store, you will need the credentials, and the credential that you used while loading data can be used here as well. So once you store the credential within the database schema, you will use the same dbms underscore cloud API for creating an external table on top of the source files that you have staged on the OCI object store. Here's a look at how to create an external table within the autonomous data warehouse. In this example, you're creating an external table called channels underscore ext. You're using the same credentials that was used for loading data into the OCI object store and specify the file URI list. In this example, you're using the same chan underscore v3.dat file. And in addition to that, you're specifying the column list. And in this example, we are using columns channel underscore ID, channel underscore desk, etc. And once this package is executed, you're creating a logical representation for this file as an external table within the ADW database. And from that point onwards, you can query that file as a external table within ADW. So in this example, select count star from channels underscore ext will give a count of the total number of rows that are present in the chan underscore v3.file that is located in the object store in the demo underscore data bucket of the DWCS demo tenancy. In ADW, you also have capabilities of using built-in SQL worksheets and notebooks. And you can use this for running queries without the need to install a client query tool. We initially support SQL and PL SQL, but more languages are in the roadmap. And this is based on the Apache Zeppelin technology. Scaling your database on demand is a very easy process. You can scale your database independently for compute or storage, and resizing occurs instantly with your database fully online. Note that memory, I/O bandwidth, and concurrency scales linearly with CPU. You can close your database to save money when not used and restart it instantly. When you provision an ADW database, the database initialization parameters are optimized for data warehousing workloads. Memory parallelism and sessions parameters are configured based on the number of CPUs. Users can modify a limited set of parameters, example, the NLS settings. Users do not have to worry about table space management because the autonomous data warehouse service takes care of this. And it has predefined data and temporary table spaces. Users cannot create or modify table spaces. Note that all tables are compressed using hybrid columnar compression. Users cannot change compression method or disable compression. Optimizer stats are gathered automatically during direct load operations. Users can gather stats manually if they want. Optimizer hints are ignored by default. Users can enable hints explicitly. Also, result cache is enabled for all queries by default. We also provide a simplified monitoring mechanism using the web-based service console. You can monitor the performance of your real-time queries as well as historical queries. You can also look at historical data load monitoring. The Autonomous Data Warehouse Cloud automatically backs up your database for you. The retention period for backups is 60 days. You can restore and recover your database to any point in time in this retention period. Autonomous Data Warehouse Cloud automatic backups provide weekly full backups and daily incremental backups. Manual backups for your ADW database is not needed, but You can do manual backups using the Cloud Console if you want to take backups before any major changes. For example, before ETL processing to make restore and recovery faster. The manual backups are put in your Cloud Object Storage bucket. When you initiate a point-in-time recovery, Autonomous Data Warehouse Cloud decides which backup to use for faster recovery. You can initiate backup recovery for your Autonomous Data Warehouse Cloud database using the Cloud Console. Autonomous Data Warehouse Cloud automatically restores and recovers your database to the point in time you specify. Let us now look at a demo for the Autonomous Data Warehouse. I have logged into my Cloud Console and I'm now going to click on menu here and click on Autonomous Data Warehouse, and over here I have selected the compartment that I'm going to be using for creating this Autonomous Data Warehouse. So let's get started. I'll click on Create Autonomous Data Warehouse and I will specify a display name and then name the database. I will go with the 1 CPU core count and 1 terabyte of storage. Note that you can start off with up to 128 cores per database or 128 terabytes for the database storage. I have to then specify the password for the administrator. The passwords need to match and I also need to meet certain complexities. I can go with the license type of license included model, or I can also use the bring your own license model. In this example, I will go with the bring your own license model. If needed, I can also tag this service. I'll click on Create Autonomous Data Warehouse and the data warehouse should get provisioned in a few minutes. The test data warehouse is now ready. Let's look into this in detail. You can see that the test data warehouse is running database version 18033. It has a core count of 1 and storage capacity of 1 terabytes. Here you can see additional details like the OCI for the database and also the license type and the lifecycle state of available. Since this database was recently created, you don't see any backups here, but once a few days go by, you'll see a lot of backups in this list. You can click on the database connection to look at the connection string information as well as to download the client credentials. I will click on download here and I'm going to give it a password, and please note that this password doesn't need to be the same as the administrator password. This password is something different and you might need this password when connecting to the Autonomous Data Warehouse from your SQL client. I'm going to download this wallet file to my downloads folder on my laptop. I'm going to leave it there and let's look at additional things that you can do here. I can scale up or down the service from this button. I can increase the core count to 2 and increase the storage to 2, let's say. I'll click on update and the scaling happens while the service is still running. That's why you'll see this green color here. Now, additional things I can do here is I can change the admin password, or if there were backups available, I could click on restore, and I can click on service console to access the service console for this database. So within the service console, you'll see the storage utilization, the CPU utilization, as well as SQL statements that are running and the average SQL response time. I can click on activity to see the activities happening on the database. Since this is a new database, there's not much going on here. Over here you can see database activity, CPU utilization, the running statements, and the queued statements. This is the real-time view, and over a period of time, if you want to go back and look at historical uh, statistics, you can click on time period, and you can also change the time stamps to the range of time that you want to look this database activity or SQL activity. And clicking on monitored SQL shows you information about statements. Over here you can see SQL plans, etc. Now the only other thing that's left here is the administration link. Clicking on that gives me the access to download client credentials. Over here again, you can set resource management rules. For example, you can change the query runtime or amount of I/O that can be consumed for different consumer groups if needed. You can set the administrator password. You can send us feedback, or if you're going to use this autonomous data warehouse to develop applications, you can download the instant client from here. If you want to use the browser-based method of executing SQL queries, you'll have to create a machine learning user and use that machine learning account for executing the queries. So let's get started. I will click on this link here. I'll click on plus. I'm giving the user a name. I'm going to use fake credentials and click on create. The account gets created. Now I can reset the password over here for this user so that I can use it for the demo. I'll save the modified password, and now I can click on this home icon to take me to the Oracle Machine Learning homepage. I will now log in with the user and credentials that I created in a previous step. So once I'm logged in, I can see the default workspace that I'm assigned to and also the user that I'm logged in as. I can click on examples to see examples that are already provided by Oracle. I won't spend too much time over here. I just wanted to show you that there's a lot of stuff already provided. Now let's quickly see how you can run a SQL script. So I'll get to the home page and click on run SQL statements. And I'll type a simple statement. I'm going to select the system date from the database, and I'll click on this icon here, and the database returns the results of the query and gives me today's system date and the current time. So that concludes the demo of the Oracle machine learning functionality within the autonomous database. Let me get back to the autonomous database page, and you can see that the scaling operation has now completed successfully. I can stop the database by clicking this button, and now I can do additional things like apply tags to the database if needed. So let's now look at connecting to this database using the client credentials file that was downloaded earlier. I have launched Oracle SQL Developer. Now, to create a new connection to the autonomous data warehouse, I'm going to click on the plus icon here. I'll give the connection a name, provide the credentials for the admin account, select Cloud Wallet, and browse to the client credentials file that I downloaded earlier. Over here, I can use the high connection service. Let me test connectivity. So the connection was successfully tested. So I can click on connect to connect to this service. Once I get connected, I will be presented with a SQL worksheet. And there you go. There's the worksheet, and let me just run a test query. Yeah, and there you can see I'm able to connect to the database. I can run queries over here. So this concludes the demo. In this demo, you saw how you can create an autonomous database in OCI. You saw how we can scale up the database, and you learned how to download the client credentials and then use the client credentials to connect to the autonomous database. And you also saw some basic things like monitoring and creating machine learning users. Let us now look at the autonomous transaction processing service in detail. To provision ATP, you need to answer 6 simple questions. You need to provide the compartment name, the display name, database name, select the number of CPUs, the number of terabytes of storage, and provide the admin password. Once you do that, your service will be created in a few minutes, regardless of the size. And once the service is provisioned, you'll be able to connect to it using SQLnet. Let us now look at the provisioning demo. I have logged into my Oracle Cloud Infrastructure account. I'll click on Menu, then I'll click on Autonomous Transaction Processing. I'll select the Sandbox 2 compartment, and I'll click on Create Autonomous Transaction Processing Database. I'll change the display name and name the database. I will go with 1 CPU core count and 1 terabyte of storage. And note that the available cores are subject to your tenancy's service limits here. So I can only provision 1 core. I'll then specify the admin password. Note that the passwords need to match here, and the password also needs to obey certain complexity rules. For license type, I have 2 choices. I can go with the license included model, or I can bring my licenses to OCI. I will go with the first option, which is bring my license. If needed, I can also tag the database that I'm deploying. I'll click on create, and the provisioning process is going to start off here. This process will take a few minutes to complete. Let's move on to the next section. REST APIs are available for all autonomous transaction processing operations. So in this example, you're looking at the documentation which shows you the REST API available to update an autonomous database. Similarly, you have APIs to delete autonomous database, to restore autonomous database, start, stop, etc. Let's now look at connecting to an autonomous database. There are predefined services for autonomous transaction processing. They are high, medium, low, and parallel. The high service gets a resource management plan share of 8 and has manual parallelism, whereas the medium gets a resource management plan share of 4 and the low gets a resource management plan share of 1. For parallel service, you have the resource management plan share of 1, and the parallelism is determined by the CPU count parameter. So as you increase the CPU count, your parallelism will increase for the parallel service. Recommendation for transaction processing queries is to always use high, medium, or low services, whereas if you want to use the autonomous transaction processing for reporting or batch processing, you can use the parallel service name. Let us now see a demo of how to download the security wallet for the autonomous transaction processing. I have logged back into my Oracle Cloud Infrastructure console and I'm going to click on Test ATP. Now I'm looking at the Test ATP Autonomous Transaction Processing database. To download the client credentials, I'll click on DB connection and then I'll click on download. I will have to then specify a password. The passwords need to match, and I would also recommend that you do not use the same password as the admin password when you download this wallet. Clicking on the download button will prompt me to save the file to my laptop, and I will click on Save File. I have now downloaded the client credentials file to my laptop. We will now see a demo of how you can connect to an ATP database using SQLDeveloper. Launch SQLDeveloper and then click on the plus icon to create a new connection. Give the connection a name and use the admin username. Provide the password for the admin user which was used while provisioning the database. Use Cloud Wallet for connection type. Specify the client credentials file that you downloaded earlier. You can use high, medium, or low for this exercise, doesn't matter. I'll go with medium. I'll quickly test to make sure that I've used the right credentials. And I get a result of success, so the credentials were correct. So I will now click on connect to connect to the database. This should take me a few seconds, and once the connection happens, I will be presented with a SQL worksheet which will let me run queries against the database. And there you go, the SQL worksheet is now available, and I can run queries against my ATP database. And that's how easy it is to connect to an autonomous database from SQLDeveloper. In the next section, you'll look at loading data into Oracle Autonomous Database. You have two data loading options. One is data loading via SQLnet, which is suitable for small volumes of data and requires the use of the SQL Loader utility from a local file system on client. You can use ETL scripts that use DML to insert or update data. The second choice is to stage data in Oracle Object Storage and then load data into the autonomous database using a new PL/SQL API or data pump import. Data can be loaded directly from any object store. We support Oracle Object Store, AWS S3, or Azure. The data can be in any supported Oracle_loader file format. As a short-term roadmap item, we are going to be supporting Hadoop file format. As you saw in the autonomous data warehouse lesson, the first step to load data into an autonomous transaction processing database requires you to create credentials, or you can use an existing credential that you previously created. To create credentials in autonomous transaction processing, you will require the Oracle Cloud Infrastructure Object Store username and Swift password. The credential will be stored in the database schema once and used for accessing the object store for all loads. So in this example, you see below that the dbms_cloud.create credential package procedure is invoked to create a credential with name obj_store_cred using username of tenant1 and a password of password. To load data directly into the target database table without any intermediate steps, you will have to first stage the data in the Oracle Cloud Infrastructure Object Store, use the credential that you created in the previous step, and then use the dbms_cloud.copy_data package procedure. In this example, you're loading data into the channels table using the obj_store_cred credential that was created in the previous step. And the data is residing in Ashburn region in a DWCS demo tenancy, which is having a bucket named demo_data, and the file name is chan_v3.dat. So when this procedure is executed, the channels table will be loaded with the data in chan_v3.dat file. You can also load data into autonomous database using SQL Developer. So in this screenshot, you're seeing that there is a connection made from SQL Developer to an autonomous DW database, and then you will right click on the table and click on import data. When you do that, a new screen pops up and you can select the source as Oracle Cloud Storage and you specify the file name using the full URL to the file, and you can specify the file format also in this example. For the credential, you'll have to specify the credential that was used. Let us now look at scaling autonomous transaction processing. We will look at a quick demo of scaling and autonomous transaction processing here. I'm logged back into my Oracle Cloud Infrastructure account. I'll select the test ATP database and I will now scale it up by clicking on the scale up down button. I'll select the CPU core count of 2 and click on update. So the scaling operation now kicks in and the autonomous transaction processing backend will start scaling up this database from 1 core to 2 core. That's how easy it is to scale up a database in autonomous transaction processing. Now from the service console point of view, this is exactly identical to how it is in autonomous data warehouse. You have the same capabilities of looking at CPU utilization, running statements. You can monitor activity real time and over a time period. You can monitor SQL. You also have the option of downloading client credentials over here, setting resource management rules, setting administrator password, etc. This is all exactly identical to the autonomous data warehouse. The test ATP database has now been scaled up from 1 core to 2 CPU cores, as you can see in this picture. In today's lesson, you learned about the different features of Autonomous Transaction Processing Cloud Service and Autonomous Transaction Processing Cloud Service. You saw how easy it is to launch an autonomous data warehouse and autonomous transaction processing service on Oracle Cloud Infrastructure. You saw how you can download the client credentials file and use it to connect to ADW or ATP using SQL Developer. And you learned about the different ways of loading data or querying data from ADW or ATP. And you also saw how you can scale up or down the ADW or ATP from a core or storage perspective. And you looked at the administration aspects in terms of monitoring the ADW or ATP service. And we saw briefly how you can use Oracle machine learning capabilities that is built in into ATP and ADW. And finally, we also saw something about the backup and recovery mechanism in ADW or ATP. In this page, you can find links to pages which has information on autonomous data warehouse documentation, autonomous data warehouse administration, and also information on migrating Amazon Redshift to Autonomous Data Warehouse Cloud. Thank you for joining me in today's lesson. I hope you found it useful. Thanks and have a great day.